All right, so we are going over the review for the iQuiz, and in this situation, the airlines typically overbook the seats on their flights because they expect 11% of passengers to cancel or not show at the last minute. Empty seats are not profitable, so they use this to estimate to overbook seats to make sure the plane is as full as possible to maximize revenue. If too few passengers cancel, then the airline must remove passengers from that flight, sometimes forcibly, and arrange alternate travel, decreasing customer satisfaction and increasing costs. 10 flights were randomly selected, and they found that 138 of 1,450 passengers on those flights canceled at the last minute or did not show up. So state a correct pair of hypotheses for this scenario. Make sure to define your parameter. So this is pretty much the state portion of an inference test or significance test. The only thing I'm adding is I'm going ahead and the only piece missing is the alpha. If it's not specified, you use the default, which is 0.05. So make sure you define P represents a true proportion of all passengers that will cancel or not show up for a flight at the last minute. Now, the null is they expect 11%, so that is our assumption going in. Now, there are consequences for both high values and low values. So here, and I'm not saying, and have no reason to believe that it's high instead of low or low instead of high. On your quiz, because the type 2 consequences and type 1 consequences are complicated when it's two-sided, I only do it one-sided. So your quiz will say unusually high or unusually low. And so if it's unusually low, you would say it's less than. That is your concern. If it said unusually high, your concern is that it's greater than. Here, I don't have that, so I'm doing a two-sided hypothesis test. So, in context, explain what a type 1 error would be and its consequences. So the type 1 error, the way I keep these straight, the 1 tells you the first one is true, all right? But we believe the other one is true because of our data, all right? So I have to, because this is a two-sided, there are two different consequences for a type 1. For your one-sided hypothesis, there will only be one consequence because you're either going to be, the alternate is either higher or lower, but not both. This one, it's both. So let's first take the scenario where we believe that it is lower when it's really 0.11. Find it easier to kind of make up a number. So let's pretend it's a 7% cancellation rate. We think it's a 7% cancellation rate instead of an 11% cancellation rate. So we think less people are canceling, so we don't sell as many seats, and that reduces our revenue, right? Because more people don't show up than we expected. All right, let's pretend now we'll look at the other case. We have a sample that makes us think it's higher, so maybe 15%, instead of what it really is, which is 11%. If we believe the proportion is higher, well, we're going to oversell more, we're going to overbook more, but we won't have enough cancellations, so we'll have sell too many seats and have to rebook passengers and increase costs and delays, by the way. So, which affects customer satisfaction. So for type 2, it's going to be similar. So, but we're going to believe the other one will be true. All right. So type 1, the first one is really true, but we have data that leads us to believe the other one. Type 2, the second one is really true, but we have data that leads us to not fail to reject H naught. We think the first one's true. Okay. So we believe that it's really 11%. So since this is two-sided, again, I have to think about two different scenarios. If we believe it's 11%, but it's actually lower, we sell too many seats and have to rebook passengers and increase costs, all right? But if it is actually higher, we will sell too few seats, reducing revenue, all right? So if it's really, say, 15%, then we're not selling enough seats. I mean, sorry, if it's actually 15% instead of 11%, then we don't sell enough seats, so our revenue is reduced. Okay. Now on to the plan portion. State the inference procedure and determine if conditions have been met. This is a one proportion z-test because we're looking at the proportion of passengers who are not on that flight, all right? They either canceled or they just didn't show up. So the three conditions are a random sample, and we told you that a random sample of flights were 15 flights were randomly selected, all right? We do the large counts, also known as large sample. Remember to use the hypothetical P, which would be a 0.11. Do not use you should not need to look at this to do your conditions since you already have a P up here, okay? So you don't need your sample. Now, PowerPoint, hold on. Here we go. So you don't need to look at that sample for this part when doing a hypothesis test. So predicted successes, go ahead and calculate it. I mean, you don't necessarily have to say greater than 10, but you need to at least calculate it to show that it's greater than 10, and it's not that much extra to say, hey, that's greater than 10. And then you've got the 10% condition, which is 1450 is less than 10% of all passengers. I probably should say it's reasonable to assume that 1450 is less than 10% of all passengers. And then finally, we can then say all conditions are met. And hold on a second, let me go ahead and highlight that. If you just tell me this piece, all conditions are met, you do not need to have the rest of that sentence there, okay? So not necessary. Now this next piece, I know I'm showing you a bunch of math here, but really in reality, you can do all of this on the calculator. Make sure you go to a one prop z-test, which is the 5 function on your calculator. So you're going to hit stat, then test, and get one prop z-test. Then make sure you put in your, let me go ahead and highlight this. First of all, let's point out this. So make sure you put in your hypothesized value. So P naught stands for the hypothesized value. It does not stand for the true value, okay? It's just the hypothesized one. How many successes you have, how big the sample size is, and then this should match your alternate. So a lot of people get confused on these two because they're like, oh, did we change the position on our hypotheses? No, what you do is you take that number, 0.11. So we're going to say that our true proportion is either not equal to 0.11, it is less than 0.11, or it is greater than 0.11, all right? So on the calculator, that is the thing that comes up. Then once you calculate it, you will see the two things. You only have to report two things here. You need to give me this z, which is your test statistic. So write z equals negative 1.8045, or you can say negative 1.8045, all right? Or you can even say negative 1.80. Okay. Then this next part, remember, that's not your true proportion. This is your p-value, the probability of getting that 0.095 or more extreme, given that the true proportion is 0.11. So don't write p equals 0.0711. Otherwise, I'm going to think, oh, he or she thinks the true proportion of passengers canceling is 0.0711. No, what that is, it's a 7% probability of getting 0.095 or lower, actually, or more extreme, because this is two-sided, given that the true value is 0.11. Now, let me just talk about the by hand calculation so you understand them. The reason there's a 2 here is this is two-sided. Our sample is below our hypothesized value. So if I just wanted the probability of 0.095 or less, I would say lower is negative infinity, upper is 0.09517. The mean is 0.11 because that's our hypothesized value. I got the standard deviation, just like we did in sampling distributions, by plugging into this formula and put it there. So if I wanted less than, it would just be this normal piece right here. But since it's two-sided, I also have to include the same size high piece, and that's where that 2 comes from. And you can see I get exactly the same value. So again, you can do this by hand, but it's super fast doing it by a calculator. If it's multiple choice, always do by calculator. You can probably get away with it by calculator on free response as well. Okay, now last part, the conclusion. The conclusion always has two sentences. It talks about the p-value, alpha, and the null, the first one. So our p-value is basically telling us how unusual our sample is. If the probability is less than our alpha, usually 0.05, then we're like, oh, that's surprising. Maybe we should change our model, so we reject our null. If the p-value is high, like it is in this situation at 7%, doesn't feel that high, but it's higher than the 0.05, we're like, okay, that's not that unusual for this model, so we don't, we're not suspicious about our model. We fail to reject it. Now, we don't say we accept it because we didn't prove that the cancellation rate is 11%. We actually got 9% on our sample, right? So we don't say, we said, oh, the null is true. No, we actually don't know that. We just don't change away from the null. Why? Because our data is not that convincing that the alternate is true, that the proportion of passengers who will cancel or not show up at the last minute is not 11%. Now, if the p-value is low, then that's unusual. That's strong and convincing, or it's convincing statistical evidence that the alternate is true. So the second sentence is always about the evidence, whether it's strong or convincing or not. Say convincing, you don't have to say strong. And it's about whether the alternate is really true. Good luck on your quiz. Don't forget to state your significance level in part 1 and turn it in. Also, page 31 of your notes, a packet is very helpful, and so are the I2 notes.